Okay, we're not going to get through the entire concept today. However, we are going to talk a little bit more in depth about the law of signs. So you guys all look at this and you say it's a bad one, okay? And
she needs a timeout.
yeah, probably. She had some coffee. She probably does. Okay. So, in geometry, you guys basically just deciphered two categories, like things that work for those congruence like theorems and things that don't, and you came up with things that help you remember the things that don't, like the AAA and the one that's a bad word or whatever, right? Okay. So the angle issue is that you can make any triangle any size with three angles, so we still can't solve that today. If I just give you three angles, you have no indication as to what's happening. Angle side is a little more complicated. The reason it didn't meet your triangle requirements is because technically I could draw a certain side length that's fixed, connect to that an angle that's fixed, but because you haven't said how long this side has to be, I might be able to connect it like this, or I might be able to connect it like this. So the reason it can't be a property in that congruence theorem is because if you can build a triangle, it's possible that it could be built two ways. Maybe it can just be built one way, or maybe this one's not even long enough to like connect to the other side, okay? So it's a little deeper than just like it's a bad word and that's why we didn't use it in geometry, right? It actually has like, it's so close to being like angle, not even close. We cannot do anything with it. Angle side, so close. Like if we knew it for sure made a triangle, we could say that ours are either congruent or they're one of two things. That's not enough in geometry to say they meet the congruence criteria. So that's why we kick it out. Here, what it means is that when we're trying to solve a triangle, but it's in this category, there could be more than one, or it might not actually be a triangle. Does that make sense to everybody? So the other ones, they give me three sides. Side was a congruence principle. Like that's why I can just start solving the triangle because I know that there's only one way to build it. Same with side or angle side angle. But this one has some ambiguity, okay? So we're gonna use that word, ambiguous. Okay, they actually call this the ambiguous case of the law of signs, okay? So basically, this is what I just said, okay? When solving for a triangle in this situation, so make a note to yourself. This is if we are given the angle side scenario, okay? If you're given angle side angle, how many triangles exist? One. That's why it worked as a geometry congruence principle. It can only be built one way. That's why you knew everybody else's was congruent to yours. So angle, side, angle, I know there's one triangle, I just dive in. Somebody gives me side, angle, side information. How many ways can you build that triangle? One way. That's why it worked as a congruence theorem in your geometry class, right? So you dive in. This one didn't work because it has all these different things that could be happening, and that's what we have to analyze. Because maybe there is just one. How do we figure that out? Maybe it's two ways. Then we want to build both those possibilities and say these two are both possibilities in this situation. And what if it doesn't actually work? How would we know? So that's what we want to know. Like there's either none, one, or two, but how can we tell? Okay? And so first you want to think about a couple of situations, okay? We're going to say that we're given this information about the triangle. We're going to work with triangle ABC. Again, does everybody have to call your triangle ABC? No, they could use different letters. So here's the thing. If you memorize the little stuff I'm about to put up here, and I change the letters to D, E, F, you can't just memorize rotely. Like you can't just be like a book and recall the print because you have to know what is A, what is B, what is C, okay? We're gonna deal with this situation in angle side means we're given an angle and two sides, okay? The given information we're going to look at is if we're given angle A, that's our angle. If we want it to be angle side, think about the triangle. If you actually built it, A, B, and C. Here's angle A. What side has to be included if I'm going to give you information around this triangle that fits the angle side-side association? Jake? Good. Side A actually has to be given to you, the side across from it. And that's kind of how I'm going to think about them. I'm thinking about this more than just the letter A. This is the important thing. This is the given angle. It's the only angle they're giving to me in the angle side. And then this is the side across from the angle. Then the other side could be either one of those other two, and it would fit the angle side. We're going to use B in this case. In all of our formulas, we're going to see B. Could it be C instead? Yes. And you have to be really careful. If they gave you angle B, then the letter we're using for little a is more like little b in our scenario, and all of this kind of stuff. We have to really more know what's the angle they're giving me, what's the side across from it. So we're going to stick with these letters, but know what they represent in our scenario, okay? Now, there's a couple of things right away that guarantee you have one triangle, okay? If this is angle A right here and this is the side across from it, remember how I told you guys that it could be shown two ways? Okay, so actually I'm gonna do these ones first and I'll come back to it, even though we normally check the other part first. So no solution. You guys got this yesterday. The last example we did, you guys tried to solve it and you got something that was an error on your calculator because it was no solution, meaning most likely it was about what's gonna happen here. So I'm gonna draw this one specific way every time, okay? So the first thing I'm gonna do, just because I like to draw it this way, it helps my brain work, I'm gonna put the fixed side length here that's not across from the angle. So for me, this is gonna be my side length that's called B, because that's the side I'm saying was given to me, but it's not the side across from the angle. So if I'm gonna give you these three pieces of information, angle, side across from it, and the other side, this is the other side. But they gave me a measurement, so it's a set length. I can't change it. That's why I kind of put those dots at the end to emphasize like it has to be this long, okay? Now, the other set length is the one across from it, meaning this side over here could be long or short. I know nothing, so I'm just drawing myself ample space and kind of telling myself in my mind that I can use any portion of that I want to use because that side length is not something that's been given to me, okay? That's going to be like my side C, the side that hasn't been given to me. What I'm not going to let change is this angle in here. This angle is also going to be fixed. That's the angle they gave me, angle A. Okay? So again, you could draw this in different ways. I'm going to draw it the same way every time we do one of these, so it just makes it a little easier for us to get through the problems. So I have the side that's not across from the angle right here. I have the angle, but I drew this side ridiculously long to kind of tell my mind, I don't know how big it is, and I can use whatever part I want. So here's the thing. If this is gonna be a triangle, that side across from the angle is crucial in deciding, is it no triangle, is it one triangle, or is it two, okay? This can change length right here, but it cannot be tilted up or down because this angle measurement was given and is fixed right here, okay? So what would be the minimum requirement, the length for the side across from angle A, little side A? Just visually, can you guys tell me what would be the minimum length it would have to be to make a triangle in this picture? Where does it have to be able to reach from? Morgan?
From the end of point B to the
Good. It has to be able to reach from here to complete a triangle. Is that okay with everybody? What is the shortest distance between 2 points? If I want to get from here to the corner of the room, what's the shortest way for me to do it? To work straight there, right? Okay. And here, straight for us, given that that's a line, would be like a perpendicular to that line. So the shortest distance from this point back to side C would be this. Is that okay with everybody? Okay. I'm going to call that H. That's not part of our like triangle. I'm calling it H as like the minimum height requirement to complete a triangle. Is that okay with everybody? That every time I draw this, that is the minimum height requirement. So what do you think is happening in a problem like we did yesterday when you guys tried to start law of sines and you got no solution? Why do you think you're getting no solution, meaning no triangle? What's happening visually up here? Okay, Josh? Yeah, it's not meeting the minimum height requirement. So basically your side A is like, here I am, okay? Not making it all the way to the other side. It's too short, okay? So then the question becomes, how would we know ahead of time that it was too short so we don't get caught up in something that's not actually going to work out, okay? So we basically want to check, is A at least equal to H, right? So in this scenario, A is less than H. Would you guys agree with that? But H wasn't part of my triangle. What is a way in which I could express H that describes it in terms of the given information they gave me? Remember, I'm given this angle, I'm given this side, and I'm given this side. And I know that right now, in order to have no triangle, that A is too small to be the minimum height requirement. I'm telling you guys that's really good. That's what we want to know, but I don't want to write H. I want to write something else next to there that somebody could look at their given information and calculate without having an H, because nobody gave them an H. So my question is, what's equivalent to H? What calculation can represent H from this scenario that uses only given pieces of information? So angle A's, side B's, or side A. Okay, Stefan. Okay, so when you do tan or sine or cosine, right, you have to use an angle. What's the only angle that's been given to us? A. So if we want to use A, okay, but we want to have H in it because we're trying to write something that can substitute for H. We don't want it to be A because A is what we're comparing it to, which means we want to use angle A and we want to use H and B. So we wouldn't use tangent. What would we use? Sine, because we want to use the opposite in the hypotenuse. Is that okay with everybody? Okay, so we would say the sine of angle A is equal to H divided by B. And if we got H alone in that statement, so meaning we've multiplied both sides by B, that means you don't have to use the letter H. I know you guys like the letter H as far as how it looks. It looks simpler, right? But when I'm giving you A's and B's, this other calculation is simpler because it's already been given to you. So when we tell someone we want them to look at A and see if it meets the minimum height requirement, or if A is too small, they have no triangle, the measurement we're telling them to compare it to is this calculation, B sine A. All right, so the reason that your calculation didn't work yesterday, you didn't analyze ahead of time, and if you did, you would have learned that you actually had no triangle because the side across from that angle was too small to ever meet the minimum height requirement. Is that okay with everybody? Okay, so what's happening here is I'm telling you that if you're given this information, because this information doesn't guarantee a triangle can be built one specific way, you have to go through and analyze it first, okay? All right, so what would it mean to have exactly one solution in this case? I'm going to draw the same picture. Same information is given. Here's my fixed side length. Here's my fixed angle. Here's my minimum height requirement. Okay. What would it mean for us to be able to build exactly one triangle that could only be built one way if we're in this scenario? So no triangle meant the given side across from the given angle was too short to meet the minimum height requirement. What would guarantee that if I gave you guys little sticks on your desk like this right now, what would guarantee that we all built one triangle that was exactly the same? Good. Is that okay with everybody? Exactly equal, that it could only just wedge in one exact way, that the A perfectly fits from here to here, but that exact distance is all. So in other words, in this case, the side across from the angle is exactly equal to the minimum height requirement. No extra, because then we could tilt it a little, okay? It just fits that one exact way where it just barely builds the triangle. So what that means is A is equal to the height calculation. And again, I told you guys we don't want to use H because H is not something that's being given in the information for the triangle, okay? So this is really H, but written in a way where you could just access it in your given information, okay? So third scenario, if we're looking at this case, same picture, fixed side, fixed angle. So here's my fixed side that's not across from my angle. Here's my fixed angle. Okay. We talked about that minimum height requirement being super relevant. In what scenario do we get two triangles? Okay, what is making this case so ambiguous? Taylor? Good. Technically, A would be bigger than the minimum height requirement, because then what would happen if A was longer than the minimum height requirement? You can't put it perpendicular right here because it would have a little extra piece hanging out, right? So what you have to do is tilt it to make it fit. The issue is you could tilt it this way. That gives you one option. Or you could tilt it this way, because remember, that third side length on the bottom, you don't know how long it is. So the problem is it could be a really short side that connects to this, or it could be a really long side that connects to this, okay? And so how we would know if there's two triangles is if this is here, if it's bigger. I'm leaving a little space on one side because there is a way it could get too big, okay? I could keep doing this, right? I'm going to draw some stuff right now. You guys don't have to draw. Are you ready? Like, let's say A kept getting bigger, bigger, two options still, bigger, two options still. When am I going to get to the point where there's no longer these two options? When what? Yeah, when it hits this blue line, right? What's going to happen then, right? Then there isn't this option. It can't go this way anymore, right? If it's too long, it can't go that way. So it's kind of sandwiched between two things. It has to be bigger than the minimum height requirement, but it also has a maximum it can reach. It has to be smaller than what? What is the blue line that Sherilyn was referring to? B, the other side that we were already given, right? Is this okay with everybody? Kind of the idea of what could happen. So here's what we're going to do when we look at the given information. We're actually going to analyze a couple things before we go straight to this calculation, okay? So first of all, we want to check this first, because if your A is already bigger than your B, there's no reason to do this calculation here. You already know it's going to be too big and there's just one triangle. So we want to check for like big facts that mean there's just one triangle right away, okay? So the big facts you want to check for, things we want to check. First, okay? You want to just look if that A is bigger than B. Now be really careful with the letters, you guys. I'm being pretty generic here, right? When I say A is bigger than B. So when I say A is bigger than B, remember, the A that I'm talking about is specifically the piece of information they gave me that's a side length that is specifically across from the angle they gave me. So if they change the letters, you have to be careful. Does that make sense to everybody? Okay. So first you check, is the side they gave me across the angle bigger than the other side? If it is, there's no way it could ever build two, because it can't do this like tilting in thing. Like Sherilyn said, eventually it's going to run into the blue line and be bigger than it. We can't have that happen. If that's the case right away, there's only one triangle and you don't have to do any more work to check. That's why we want to check it first. Okay? We don't want to go do these other calculations. The second thing you want to check is if it's supposed to be the biggest side. How do we know that something is supposed to be the biggest side of a triangle? It would have to be across from the biggest angle. Now, if you don't know the other angles, you don't know which one is biggest unless the one angle they gave to you is greater than or equal to 90. Right? Because if it's a right triangle or an obtuse triangle, there can't be another right or obtuse angle, right? Then that's definitely the biggest. Then you should have found the first thing to be true. A should have been bigger than B, and there should have just been one triangle. Okay? Otherwise, if A is smaller than or equal to B, they just gave you information that doesn't make sense. You can't give me a giant angle, then give me the side across from it and not have it be the biggest thing. So if it's not the biggest thing, their information does not make sense and there's no triangle. Do you guys see what I'm saying here about really not being procedural? This is not about knowing a procedure. This is about understanding, okay, how a triangle is made and what things make sense and what things don't. So we look for kind of big things that have to be true right away. And then the third scenario is to go to these situations here, okay? So A is smaller than B and angle A is smaller than 90, then you want to compare all the things that we just did. You want to see how A compares to B times the sine of A. Okay? And that is what we just did over there, right? If A is smaller than this, it didn't meet the minimum height requirement and we have no triangle. If A is exactly equal to this, then we have one triangle. If A is bigger than this, we have two because you already made sure that it wasn't the one triangle scenario. Does that make sense to everybody? So we check these things that are quick to check first. Then we go do this calculation if we're in this situation to see if that third side meets the requirement or not. Okay? Is this all right with everybody? All right, so we're gonna actually do the problems tomorrow in class, okay? So we're just gonna pause right here for today.